Welcome back to the series on Take-Home Assignment 2. You may have noticed that in my video when I said I increased the video settings, nothing happened. I apologize for that. I have actually fixed the problem now, I'm pretty sure. So it should be in 1080p, whereas it was in 720 before, which is why it looked a little blurry. Anyway, before we get moving on to the spreadsheet model here for question 5, I want to make sure I'm emphasizing something. This is a little different from the example problem we did in class last week. So you see, this is not a symmetrical matrix. In other words, it's not the same way that things were last time, where if 1 served 2, 2 served 1. It's not that simple. So A serves 1, 5, and 7, but that doesn't mean that, so you see 1, 2, 3, this doesn't go 1, 1, 2, 3 here, 1, 1, 1, 1, 1, 1. So you have to be careful this time about which direction we go on the matrix. In other words, do we want to sum product this way, sum product this way, and so on. So you just have to be careful. So, for example, area 1. So these are our areas here. So area 1 is serviced by location A, location B, location C, and location G, which means that I've set this up correctly, which is good news, and we just need to sum product our chosen locations and the corresponding location information from our data table. Now note, well, that's odd. Oh, I didn't hit comma first. That's an important step. So yes, we need to have our decision variables absolute cell referenced and our locations up in the data table, which should be relative. The function of that, of course, is that we can fill handle over, and if we've done things properly, we should have this times that. So far, so good. Now, our minimum coverage is, of course, just 1. Now, generally speaking, on the publisher solutions that I uploaded alongside of the prompt, you will find that they just leave the minimum coverage. They don't even put that on the spreadsheet and just type it into the solver dialog box, which is perfectly legitimate. I just don't personally like it. I find that it's less clear. Okay, sorry for that keystroke error there. This is what you should end up with. 4, 2, 2, 3, 6, 3, 3, given my all binaries, all 1s. All these are greater than or equal to. All of these are 1s. And then our objective function is very simple. We just sum all of our locations. So, should be 7. Now note, I want to point out as an aside here, Excel thinks we have an error. And in fact, if you go to the formula's error checking, it will tell you that formula omits adjacent cells. So remember that Excel's error checking is not the end all be all. Don't take it for its word. You have to think. You have to be careful. You are the user. Excel is just a tool. Don't be Excel's tool. Don't be a tool. Hear that? Okay, so our model's built. Our mathematical model's built. Our spreadsheet model is built. So we need our solver dialog box. So our location, our objective are the number of locations, which once again is the double bordered cell. We want to minimize our number of locations, which we control by changing our cells in red. And we have that long thing of constraints, which must be greater than or equal to 1, and our decisions must be binary. So our objective, B25, is minimized by changing B12 to B18, subject to the constraints that our decision variables are all binary, and B21 to H21 must be greater than or equal to B23 and H23. And of course, as usual, we need simplex LP. And it turns out we can sort, we can address, we can protect all 7 locations with just 2. Or all 7 areas with just 2 locations. B, which covers 1, 2, 5, and 7, which leaves E to cover 3, 4, and 6. And that covers all of our regions. And that is it for question 5. See you in a minute for question 7.